In this video, you are going to learn about scientific methods. Here is the sequence of using a scientific method. At the beginning, you're either curious about something, or you have observed something, or you may have an idea of creating something. So that starts with an observation or an idea. Then what the next step is to make a hypothesis. So what is a hypothesis? Let's write that down. Hypothesis is a testable prediction of a phenomenon. Is a testable prediction or explanation of a phenomenon. Okay, so after that, what would that be? Then you will need to perform experiments to see if your prediction or explanation is right or wrong. Okay. After many times, you can either prove that it is right or it is wrong. And then we can come to a conclusion. Let's use an example to explain the scientific method. We have students come up with an idea of making plastic heavier. Let's say we have EVA, that is a plastic name, ethylene vinyl acetate. This plastic is used to make shoes. For example, the Croc shoes, the foamy Croc shoes. Okay, so that student come up with an idea, and that is because the density of the EVA plastic is very low. So how can we make it denser? It is by adding something that has a higher density. For example, he tried to make it greener. So he can add something that's renewable, and that is starch. Before adding anything, EVA itself can float on water because the density of EVA is less than 1 gram per cubic centimeter. So here is the hypothesis. By including the starch, these are the starch particles inside this plastic, it's going to make the whole plastic composite denser. That means higher density. So that is the hypothesis. Experimentally, this student first melt the plastic. Now it's in molten state or in liquid state. And then he put in the starch powder in it and start stirring. After he mixed it well, then he can put it in certain shape that he can do the study. Okay, that's very good. So at the end, what happened is he did the experiment many times, and he put his sample, this is his sample, he put it in water, and what he observed is, yes, this material, this composite, the combination of starch and plastic together will sink in water. So that's his conclusion. So the hypothesis is by adding some filler or particles that it has a very high density to the EVA, it can increase the overall density of the mixture or of the composite. So that is the hypothesis. And he did experiment to prove his hypothesis. And the conclusion is, yes, it worked. This new material, combining the starch and the EVA plastic, yes, now it sinks in water. Does it always work like this? When someone make a hypothesis or make a prediction, does it always work like this? So the only way can tell is by performing experiment. let's look at another example. The same student, he thought that, with the same principle, he tried to increase the density of polyethylene, PE. So this polymer is recycle number 2. That means if you see a triangle, you will say number 2 over here. It is used to make, for example, buckets to carry water or many of the injection molding items. The density of this plastic, it is about anywhere around 0.95 gram per cm cube. That means it will float in water. So the student make the same hypothesis. So what he thinks is by adding starch is much denser than polyethylene. Starch is about 1.25 gram per cm cube. That is the density for starch. Okay, so the hypothesis will be if we mix certain percentage, let's say 30% of the starch into polyethylene, we can make this mixture or the combination, sometimes they call it composites, denser so that this composite can sink in water. Based on the calculation, so that's the prediction or hypothesis. Now, the student will start an experiment. He did the same way as the previous experiment. So the first thing is to melt the plastic, melt the polyethylene. The melting point of polyethylene, it is at about 120 degrees Celsius. So that is the melting point of the plastic. In order to make it that flowable, the processing temperature needs to go a little bit higher. It needs to go to 140 degrees Celsius. Now, when the student add the starch in it and start stirring it, what he have never thought of is the starch contains about 8 to 12% of water. And now when the starch get into the plastic, it starts boiling. Once this starch boils, it will form a bubble. So what happened is now the starch makes it like bubbly, like this. Here's the starch where the water inside the starch or the moisture actually boil out and form this bubble or voids. In other words, this student was foaming the polyethylene. So afterward, when he put this foam or this composite into water, what he saw was it actually flows even more. Instead of making it sink, it flows more. So as compared with the previous experiment, over here, because EVA, the melting point is about 70 degrees Celsius and the processing temperature is about 90 degrees Celsius, and the water did not boil and foam the composite. That's why it worked for EVA. However, it did not work for polyethylene, PE. So in this case, we just have demonstrated that the hypotheses not always are correct. We make the hypothesis, we thought that by adding a denser material into polyethylene, it's going to make it denser and therefore it will sink in water. However, after the experiment and after did it many times, we conclude that it did not work. By adding starch into polyethylene, by melt mixture, we cannot make anything lighter in density than just the virgin polyethylene. So that is our conclusion. And in this case, we know that our hypothesis was not right. The student knew that.